Hello YouTube viewers, welcome to my show Future Friday. In today's episode, we're gonna take a look at the emerging field of wave power. So let's dive right into it. So what it is? It's very simple. It's a renewable energy source, same as tidal energy, on which I made a video yesterday. And tidal is done by gravity, as in it's moon power, moon and solar power. This is wind power basically. So that's what it is. That's what's causing the wave. Of course, there are other effects also, that like a rotation of the earth, the Coriolis effect, and there are other things. But primarily, you can think of it as wave power, as in being wind energy. So why we have so much interest into it? First, it's an untapped market. Like let's say today you want to jump into renewable energy market and you want to make let's say solar powers. Yeah, you're gonna have some serious competition. Solar power is I made a video about that. It's almost reaching price parity. So everybody has already jumped into it, because in next coming 5 to 15 years, it's gonna become the way to produce electricity. Not because of anybody cares about the environment, but simply because it's cheap. People like cheap electricity. So if you want to compete in that market, you're gonna have tough time. This market is completely new, untested, and it just began. So there is a very large emerging market here. Second is 24/7. This is crucial. Very few renewable energy like biomass and geothermal, I made a video about that, is the only one that can provide 24/7 power. This can do that. So how does it work? Well, there are many designs, but I'm gonna narrow it down to two core aspects. First, my personal favorite is oscillating water column. Basically, it's using the wave, the motion of wave that is going up and down, to create a column of air moving back and forth. Basically, first it creates a high pressure air that moves out, and then while the wave falls, it creates a partial vacuum that drags air in. Based on that wind power, there is a turbine running. That turbine is running the generator. Benefit: nothing is submerged, nothing that is like precious, expensive, complicated. They are all in the air, so you can easily do the maintenance without even needing to go into the water. And the only thing that is submerged in water, it's concrete, which is relatively cheap. So this is one of the plant. And then we have other many people who are trying to make it work. Designs like this, where you are physically making the wave work, as in the generator to wave, there is a direct line of mechanical connection. In this sort of power plant, air is doing the motion, like your wave is being converted into air waves, as in air power, and then air power is being utilized. But in mechanical system, they are trying to directly harness it. Benefit: inherently it gives more power. Like one of these buoys can give you upwards of 20 to 30 megawatts. So these are the two primary systems. Like, of course, if you go into Wikipedia and read up, there are hundreds of designs, but these are the two primary components. One uses wave to make air, energize the air. Using that air, they extracts the energy. Second system is directly using mechanical force. So what are the cons of the system? First, it is a very big hazard. This is an even bigger hazard than what we call tidal systems, simply because it can be laid out anywhere, basically anywhere in the sea. So that creates a scenario where many of them can be put into place where they are directly into the contact with shipping lanes and marine life. So these are quite destructive to both of them, not only shipping lanes but also marine life form. So that's kind of problematic. Second, this is very weak. This is crucial aspect. Tidal energy is very substantial, as in you can actually power cities with it. This, on the other hand, it's nowhere near the actual raw power of tidal. Wave power, at best case scenario, I have linked the study below, based on NOAA study, is barely 2 terawatt. So let's say at best case scenario it's 10 terawatt, but that's not enough. Like right now, as I talk to you, I have already made a video about solar farms. We already are in a position where there are solar farms that creates 1 terawatt of power per hour. So suffice to say, we have crossed a point where solar can provide a lot of power. Heck, it can run a country. And I'm not talking about like covering everything in solar panel. I'm talking about 1 to 10% of land area in uninhabited land area, basically desert or things like that. You're gonna get the power for the nation. Only problem after that would be, how do you power it at night? So all things considered, this is very weak. Now, all the designs that I showed to you, like, they are idiotically expensive. They are very expensive. They make tidal look cheap. So like these sort of buoy designs, they barely lasted 5 months. Like some of the early designs that were tested, they broke down in 2 months and they landed on the seafloor, which created a hazard for fishermen, because they have net that goes very close to the surface. Having giant metal object, causes a trouble for them. So these are the con of it. Like this is a very rough diagram from NOAA's that they are showing how much energy do we have. As you can see, like in this area of USA, you're barely getting 5 kilowatt per meter square. That's not enough, just flat out not enough. And not to mention, the places which has a lot of power, it's not very easy to access. Like this area red, it has upwards of 60, but not easy to access. For that reason, cons are kind of high on this. Lack of power, lack of raw power, as in like even if you extract all the power that you have, it's not gonna be that much, and it's idiotically expensive. And let's not even go into the maintenance aspect of these things. So what we can expect in the future. Now, this is where things get interesting. If the designs are made that are long lasting, relatively speaking, as in it should last upwards of 30 to 50 years, then the price starts to make sense, as in people who invest into these things will get a profit. That is the crucial aspect. Nobody is going to do it if it does not make a profit. No government, no private individual. This and oscillating water column design, like this design that you can type artificial blowhole and you will start getting a lot of this design. All it does is creates a column of air that moves back and forth. So inherently, even if let's say fish ends up in this area, nothing will happen to the fish. This can become a coral reef. Nothing will happen to the structure since there is no moving part, and it has almost no detrimental effect to the sea life, to shipping lanes or things like that. And this plant, that is the oldest, it was connected to the grid in 2001. So suffice to say, this is very time-tested technology. Simply the best benefit it has, that this concrete structure can easily last 50 to 100 years. That's not an issue. We know how to build seaworthy concrete. That's the cheap part. And everything that does wear out, like turbines, valves, electronics, they are above sea. As in, you can simply go to a boat, land here, fix these things, and boom. So this design has the largest potential, not only because it does have one consequences compared to direct mechanical systems. It does produce relatively less power, but given the fact that it can last years and years and decades and decades and decades, there is no comparison. Over time, this can outlive all other systems that are direct sea systems. And not to mention this, while it does not have enough power to do the raw power lifting of the whole grid system, where you can make the whole grid renewable, this can provide a very substantial add-on to basically a grid where you are running on renewables. Let's say you have a coastal city that is running on solar power. On the night, you can rely on these. This, while they do not provide too much power, as in like this one was barely half a megawatt, and they did provide lots of megawatt to the grid, but inherently, like per hour, it's not very powerful, and it does have a lot of fluctuation. So there has to be some way to store the electricity. I could think of one way where you have, instead of AC generator, you put a DC generator and directly link giant capacitors to it. That way, if waves do fluctuate, the power output will be stabilized. So this can add as a very good stimulant or a catalyst, if you will, to any existing renewable energy. It's like small, but it's trickle charging. Basically, your grid will always have some power coming from these sort of systems. So I am very hopeful for oscillating water column design. Every other design, I'm like, no, flat out no. Like there are designs that have buoys that are going like this, and there are hydraulic coupling that is like moving the hydraulic fluid and then creating energy. Awesome, just ask the cost of it. So for this reason, for the simplicity of this design and the fact that it has almost no effect on the marine life, I am really comfortable with this sort of design. And this can the shoreline, you can easily create this on your shoreline, and you can provide you're not going to run a city with it, but you can provide a supplemental power, which is always nice. So this was my presentation on WaveEnergy. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, dislike it. And I would suggest you leave a comment what you want to see in the next episode of Future Friday. And as always, please subscribe, press the bell icon if you are free. And as always, thank you.